Question number 14.58. Part A, if the nucleotide A, Z, X, what is the number of nucleons? And the answer to that is A nucleon is a proton and a neutron, and the top number is the sum of those two. So the answer to part A is capital A. If each nucleon has mass m, what is the total mass of the nucleus? Well, we've got A nucleons and each has a mass m, so the answer to that is the product of those two. Suppose the radius of a nucleon is r0. What is the sum of the volume of spheres of the separate nuclei? So the radius of a nucleon is r0, so the volume of a nucleon, effectively the volume of a proton or a neutron, is equal to 4/3 pi r0 cubed. The question asks what is the sum of the volumes of the separate nucleons. And there's a slight typo in the question there. So the volume of the nucleons is equal to the number of nucleons multiplied by the volume of each one, which is A 4/3 pi r0 cubed. The volume of the nucleus will be similar to the sum of the volumes of the separate nuclei. So we're going to write down an expression for the density. So density is equal to mass divided by volume. Now the mass of the nucleus, we've calculated that in B, which is AM. Now the assumption we're making is the volume of the nucleus is the same as the volume of all the nucleons, of all the protons and neutrons. So we're assuming there's no gaps here, which is what we did in the lesson the other day. So I'm going to write this, which is the volume of all the protons and neutrons, on the bottom. And you can see here straight away that the A's cancel. So if I just tidy this up a little bit, I can bring the 3 from the bottom. So I've got 3m over 4 pi r0 cubed. For part E, what does this tell us? That all nuclear matter has the same density. Doesn't matter how many nucleons you've got in that nucleus, the nuclear density is always the same. That's because it is independent of A. The A's cancel here, so all it depends on is m, the mass of a nucleon, proton and neutron. That's the constant, that's the same for everything. And the radius of a proton or a neutron, we're using r0 in a slightly different way than we did in the lesson there. That's not the radius of the nucleus, it's the radius of a nucleon there. So all nuclear matter has the same density, and for part F we have to work out what that density is. The density is equal to 3 times the mass of a nucleon, which is 1.67 times 10 to the minus 27 kilograms, divided by 4 pi and it's 4 times r0. Now r0 here was the radius of a nucleon. So it's going to go off here. So when we have one nucleon, so one nucleon is when A equals 1. We've just got one nucleon, or hydrogen 1. So r0 equals our normal r0, A to the third, which is r0 times 1 to the power of a third, which just equals r0. So the r0 in here, the radius of a nucleon, is the same as the r0 we've been using previously. So we can use 1.0 times 10 to the minus 15, and we're going to cube that, and you should get approximately 2 times 10 to the 17 kilograms per meter cubed.